computer just in case like we're missing, maybe they're on vacation or something, and then let me turn on captions. So if I'm ever talking too fast, you can always like just look at the captions on the bottom of your screen. Okay. So can connect to the microphone. If you can't, if you can still hear me, that's fine. I'll be paying attention. I'll be paying more attention to the chat then. If you just have any questions, just let me know. Okay. And then let me share my screen again. So remember, it was 2 weeks ago, right? 2 weeks ago, we did the midterm, right? And hopefully you guys at least try, right? I really just want you guys, remember, I always want you guys to just try on the problems, right? This it's not easy. So of course, you're always gonna, I don't expect you guys to solve all the problems I give to you, right? But I do expect you guys to try the problems at least. I just really want you guys to try, right? Try your best, right? And then when I explain the problems, you try to listen along, make sure you understand it, and then you want to be able to get to the point where after I explain the problem, maybe like the next day, right? You should be able to do the problem completely by yourself, right? Without looking at any explanations, without looking at my explanations, without looking at any of your old code, old ideas. You should be able to start to do the problem from scratch. Danny, did you say something? I couldn't hear you. Let me turn up my volume real quick. But I think Danny, I heard you unmute. Oh, okay. Maybe it was like an accidental thing. I'm not sure. So remember, I just want you guys to try on the problems, right? Like all I can ask from you guys from this class, right, as your teacher is just try on the problems, right? Just try your best. And when I explain the solutions, I try my best to make it as understandable as possible, right? But it's up to you guys to ask questions, let me know if something doesn't make sense, right? Let me know if something doesn't make sense. Like, and then like just give me some feedback so I know how to explain it so that you can understand, right? Because my goal of explaining is so all of you guys can understand the problem, right? Whenever if I'm going too fast, because it makes sense in my head, right? I understand the problems. So like when I'm explaining it, like it makes sense. But if it doesn't make sense to you, please let me know, right? So when I'm explaining the problems, I just really want you guys to like listen along and ask questions and try to understand it, right? You want to get to the again, you want to get to the point where when maybe on the next day when you maybe try the problem again, right? Without your old code, without my explanation, without any explanation, just from scratch, starting from like level zero, you should be able to do the problem again. Why? Because you understood the process of solving the problem, right? You're not supposed to, because there's like a million problems out there, right? You can't memorize a solution to every single problem. That's impossible, right? And that's not practical because you want to get to the point where you can look at a problem and be like, okay, I kind of know how, like, when you start a problem, you're in like a dark room, right? You don't know where you're going, you don't know anything, right? But I want you guys to build the intuition. The main goal of this class, what I'm teaching you guys, is for you guys to build like the intuition, right? Like intuition is kind of just like what your brain thinks automatically when you see a problem, right? Like you should be able, I want you guys to practice looking at a problem from scratch, like, okay, this problem wants this from me, right? This problem wants me to do this, right? And I'm gonna, because I know what the problem wants from me, I'm gonna try to work my way to the solution, right? It does sound a little challenging, and it is, right? It is challenging, but if you just keep on practicing, right, keep on understanding how I got to the solution, right, or understanding how the solution works, right, you will build the intuition, which is just how your brain thinks when you see a problem, right, and you will be able to solve most of the problems, right, because the goal right now is for you guys to build the intuition, not to memorize the solution, right. You don't want to memorize the solution, right, because there's always different problems, right. I'm not gonna give you the same problem every single day, right? I'm going to give you guys a different problem. You want to build the intuition so you know how to approach the problem, right? And this is something that I'm always trying to emphasize with you guys, right? I want you guys to build the intuition to solve the problem, right? I don't, and when I'm saying understand my explanation, it's not like memorize the code, right? It's not memorize the code. It's trying to understand, okay, how did Neil, right, go from reading the problem to like how did, like what tricks did he do to try to work his way to the solution? Because when am looking at a problem, I haven't memorized every single solution to a problem, right? All I did was I started with the problem, I read it, right? And I was like, okay, there's these things that I can think about, right, that might help me solve a problem, right? There's some observations that I can look at that helps me solve the problem, right? And I want you guys to build those observations too. That's why I'm trying to get you guys to do this, right? This is not easy, of course, it's not easy, right? And I understand if you guys get frustrated and a little mad, maybe like oh, you think it's too hard, right? And it is hard, right? But I think you guys can do it. All I ask from you guys is just try the problems yourself. And when I explain the solution, explain, like, try, understand how I got to the solution, right? Understand how I'm approaching a problem. And I want you guys to like develop and use my ways and develop your own ways to do that, right? You don't have to necessarily copy my ways. Just you try to understand how I went from, being in a dark room to the solution, right? So I just want to always emphasize that is I do want you guys to try on the problems, right? When I give you guys the problems, please try on them. Like please just try, right? Don't look at the solution automatically. Don't just wait until I'm gonna do an explanation, right? Just try it, try yourself first, right? All I can ask from you guys is try for 30 minutes first, right? And then if you guys solve it, great, awesome. If you guys don't solve it, completely okay. Even if you solve it or you don't solve it, I want you guys to listen to the solution, right? Listen to my explanation of the solution. Okay. So hopefully you guys remember what the midterm problems were about, right? I'll give you guys the links again if you guys don't have them saved. I know it's been 2 weeks, but today all we're gonna do is because 2 weeks ago I promised you guys we're gonna go over the solutions to the midterm, right? And that's what we're gonna do today. Okay, we're gonna go over the midterm review, and what I'm gonna do is I'm gonna be drawing on a whiteboard. So, and I always recommend, remember, I always recommend you guys to write pseudocode. Remember, pseudocode, when you're approaching a problem, you want to get your ideas down on a piece of paper. Why? Because problems, there's always many parts to a problem, right? You're gonna have many ideas on how you solve a problem because you guys are creative, right? You guys are creative. Your brain will work and always think of, okay, I can do this to solve a problem, I can do this to solve a problem, right? And there's gonna be a lot of ideas, right? You're gonna be throwing a lot of ideas around. Some of them might work, some of them might not work, right? But if you get your ideas down on a piece of paper, it'll be very easy for you guys to determine, okay, what has worked so far, what doesn't work so far, right? And you don't spend your time on things that like you've thought about a solution, right? It doesn't work, right? You determine it doesn't work, and like 5 minutes later, when you're still thinking about a solution, you don't want to think about the same solution again, right? Because that's you're just wasting your time, right? So I want you guys to pseudocode will help you organize your thoughts in order, and it's like a guide to like help you solve a problem, right? Like when you're jotting things down or you're writing, okay, this will work. I can do this first, then I can do this, and I can do this. Then eventually you will be able to solve a problem, right? It'll help you work towards the solution, right? And um, like some observations is sometimes you guys might want to like take the easy way out. Maybe you can just say, okay, I want to use a for loop. Okay, I want to use a while loop. I want to use a list. I want to define variables, right? Those, of course, okay, great. You definitely need to know that. But the issue is every single problem, you're going to use a for loop, probably. Every single problem, you're going to define variables. Every single problem, you might use a while loop, right? Those are very broad, right? You want things, um, you want to like get from broad to specific. That's how you get to a solution, right? When you just start a problem, you're of course going to have broad ideas, right? But you want to narrow it down eventually to concrete things like, okay, I'm going to define these variables, and these variables have this type of function. Maybe it's to store a list. Maybe it's to count how many times I saw something. Maybe it's to hold like a number, like a sum, right? Like there's always just many ways to define a variable, right? But you want to get the when you're solving a problem, you want to know what variable will do exactly what, right? And that is what pseudocode will help you do, right? So I want you guys to go from broad to specific when you're doing the problem. Okay, hopefully that makes sense. I'm gonna say that a lot, so hopefully you guys can kind of understand like the general gist of why I'm doing pseudocode. Right? Pseudocode is very important. I highly recommend you guys to do it. Okay, so cool. So today let's just do a midterm review, right? So problems we had on the midterm. Let me send this to you, right? So let me send this to you. And after I open this, I'm gonna move to a whiteboard and we're gonna look at the problems together. Okay. So first we're gonna talk about contains duplicate. Okay, contains duplicate. So let's all open the problem. Remember, I want you guys to follow along, right? Don't just go on YouTube or something while I'm explaining because then you don't learn anything, right? And this class is kind of useless to you, right? So please follow along, right? Open the problem. Let's read it together. Let's understand it, and then let's go over the solution. Okay. So this, right? The thing is only one sentence long, so maybe it should be. Hopefully, at least you understood what you were supposed to do, right? So, given an integer array nums, return true if any value appears. Sorry. Return true if any value appears at least twice in the array. So I want you guys to think, okay, what does at least twice mean? Tell me, what does at least twice mean? And they bolded it, so it's probably very important. So just want to let me know what at least twice means. Like duplicate. Um, yeah, it's kind of like you see it twice, you see it two times, or you see it more than two times, right? So like you see it, that's what at least twice means, right? So when you're looking at the problem, you want to understand, okay, what each thing specific, what the words mean, right? You want to understand the problem. So we're right now, so far, what I just read, right? Give it an integer array, nums, return true if any value appears twice in the array. Right, at least twice in the array means it appears either two times or more than two times, three times, four times, five times, six times, 1,000 times, right? Two times or more than two times, right? So if any value in the list appears more than two times or two times, we're going to return true. Otherwise, we return false, right? Okay, cool. And well, always look at the examples, right? The examples help you solve the problem, right? So now you can kind of see, okay, well, now that I see, okay, if any value, any single value appears two times or more than two times, I'm going to return true, right? Otherwise, I'm going to return false. That's what the problem says. So now that's what I think the problem says. So let's see if it actually is what the problem says. So let's see why this thing returned true. Remember, we return true if any value appears two times or more than two times, right? And we can see here that one clearly appears two times, right? So that's why we return true because, well, any value, right? The value, this any value, the sum is one, right? Appears two times or more than two times. So one appeared two times, right? And they give you a nice little explanation too. Element one appears at zeros, indices 0 and 3, right? 0, 1, 2, 3. So there's a 1 at index 0 and there's a 1 at index 3. Right? Okay. So now let's look at this, right? 1, 2, 3, 4, false. Why do we return false? Because if we look at every single value, they all appear one time, right? No times did we like see a value that appeared twice or more, right? So that's why we return false. All elements are distinct, right? Example three, nums. This is definitely true, right? Because you can instantly see that one appears three times, right? Which is more than two. So we return true. So does this problem make sense to you guys? Okay. Hopefully it does. I hope the problem makes sense. Because if a problem doesn't make sense to you, then you're probably not going to understand the solution, right? So let me know if it makes sense or if it doesn't make sense, okay? Okay, can I move on? Any questions? What the problem means? Like anything you can like type it to me in the chat or like you can unmute. Anything is okay. Okay, I'm gonna wait like maybe like a minute. Maybe you guys are like typing something. You can read the problem right now. Hopefully you have the problem open as well. So does this problem make sense? I'm gonna wait like a minute if you guys are like typing these in the chat or something. Okay. Okay, so it's been like a minute, so hopefully the problem makes sense, right? Because if you guys don't understand the problem, you're not gonna understand the solution, right? You're like you gotta know what you're trying to solve, like what the goal of the problem is, right? So we want to see if any value in the list appears two times or more than two times, we return true. Otherwise, we return false, right? Okay. So let me open a whiteboard now, and I don't want you guys to please don't draw on the whiteboard, because when I open a whiteboard, anyone can draw, but I don't draw on the whiteboard, please. Okay. Thank you. So let's quickly look at the problem, right? So let's, for example, one, okay, 1, 2, 3, 4. This is our nums list. Remember, nums is given to us, right? Because that's how leak code problems work, right? So, okay, let's think. What makes this thing false? Why is this false? Right? Oh, okay. Try to draw on the whiteboard. Thank you. Just like, get your hands off your mouse. So like you don't go too crazy. Because when I move, your screen will fall on my screen. So don't worry about that. Okay. So why is this false? Right? Why is this false? Let's see. So our goal right now is we want to see, okay, well, I have a list. I want to see if any value appears two times or more than two times. Right? So let's how about you guys give me some ideas? What might you guys use? right? Like how might you guys approach the problem? I want to see what you guys are thinking right now. So you can type it to me in the chat. Okay, don't write on the whiteboard, just type it to me in the chat. Okay. And right now you can give me some like broad, just throw anything out there. You could say for loop, you could say variables. Just throw anything out there, and I want you guys to get more specific later on. Okay. Cool. So I see some broad ideas when they're good ideas, but now I want you to tell me how will the thing you just told me, how will you use it? Like I see like a while loop. How will you use a while loop? Like tell me exactly how you will use a while loop. Or not exactly like don't write me the code, just like tell me, okay, what are you gonna use a while loop for? Like what's it gonna be for? What's the while loop gonna be for? What's len gonna be used for? Okay. You guys maybe like a minute, maybe like you're typing in the chat takes a while. While there's less than okay, so Alan, you have a very interesting idea. So while there's less than two same numbers in a list, it'll be false. Okay, I see what you mean. Okay, cool. So then, okay, so while there's less than two same numbers in a list, it'll be false. Okay, cool. So then this maybe like the detail that you might have missed out on because the issue is while there's less than two same numbers, there's less than two same numbers in the list, it'll be false. So you're saying that if I were to put this nums list in a wild list, right? One, two, three, four, right? There's less than two same numbers in the list, right? That means it'll be false, like you're just gonna run it on forever, or like what will you do? Like I'm thinking maybe like you want to like remove something or but like, if you just say that like it was run on forever, like I don't, you know, not sure. But like Anna, you gave like also an interesting idea. So you find the length of nums, then find the length not including the duplicates of the nums. See if they're equivalent. So yes, that is a great idea. So how will again we want to get more in detail, right? So how are we gonna find the length of not including the duplicates? How are we gonna find that? Like how are we going to find the length of the list not containing any duplicates? Like what might we use, right? There is something that we learn that will help us, but like, how might we do that, right? It's a good idea, but we want to get to the more specifics. So yes, that is a good idea. So, Anna said that we can use a set, right? So Anna said that we can use a set, right? And Anna, do you want to like tell us like what does a set do? What does a set do? Like what's so special about a set? Um, are you talking about like the length of the set, or are you just talking about like what a set does? Like what's special about a set compared to a list? Yeah. Um, okay, yeah, I think it's a general idea. So a set is a list, but it can't contain duplicates, right? And remember from module one, right? We said that remember that we said a set, even if you add duplicates in it, Python will automatically remove it, right? Just Python remove it for you. How convenient is that, right? So it'll remove it for you, right? So and remember how you convert something to a set, right? All we have to do is set, and we just pass it in the variable name that is a list, right? So when this happens, right now we have a set of the list one, two, three, four, right? So Python, remember, it'll automatically remove the duplicates for you when you convert into a set, right? That's very convenient, right? So now this will be one, two, three, four, right? And Anna had also like a good observation, right? And okay, let me give you another example. Maybe this is like kind of a bad example. So like if nums, this is like two different things, right? So if nums was equal to let's say one, um, I think like the first example is like this, right? If when we do sets of nums, right, this will equal to 1, 2, 3. And you can see how like the duplicate one got removed, right? Because Python just automatically does it for you. Very convenient. Very convenient, right? So now you can kind of animate a good observation, right? You can see that, okay, when the set contains a duplicate, right? Or sorry, when the list contains a duplicate and we convert it to a set, the length will change, right? Because the duplicates were removed, right? So the list got shorter, right? List got shorter. So the length of the list is different, right? So if there is a duplicate in the list and we were to remove the duplicates, wouldn't that make the list shorter, right? Because we remove the duplicates, right? If there's duplicates in the list and we remove them, right, then it's shorter, right? So, right, and how we remove the duplicates is just convert it to a set and look at the length, right? Because when the set function in Python, right, it'll remove the duplicates for you, right? So we could check the length of the list, right, and the list after we remove the duplicates, which is just the set of the list, right? We convert the list to a set, right? So if we were to look at the length of the list at the start, right, and we convert that list to a set and we look at the length again, the lengths are different. That tells us there are duplicates, right? Because we remove the duplicates, so the length changed, right? And if there aren't any duplicates, like the example on the left, right? 1, 2, 3, 4, there's no duplicates, right? If we were to convert it to a set, we still would get 1, 2, 3, 4 because we removed no duplicates, so the length is the same. So the length is the same. All right, so now let me ask you guys a question now. I want you guys to all think about this. So let's just say our nums is, let's say nums is our original list, right? Let's say it's 1, 2, 3, 4. And we will make it so now we have nums, let's call it this, nums, no duplicates equals to set nums. Okay, set nums. Cool, right? Okay, so remember, this was just the thing we explained. Now we have our original list and we have our list with no duplicates, right? So let me ask you guys a question. If length of nums does not equal to length of nums no duplicates, what does this tell us? What will this tell us? So the length of our original list does not equal to the length of our list without duplicates. After we remove the duplicates, what does this tell us? What does this tell us? Can someone like type in the chat or like just unmute maybe, or just like say something? This time I want you guys to maybe you can write it like on the whiteboard if you want to. Right, there's duplicates, right? There are duplicates, and that's great, right? That's exactly right, right? So len of nums does not equal to len of none of duplicates, right? If our original list has duplicates, right, and we were to remove the duplicates, that means shouldn't the list that we remove should get shorter, right? Get shorter, right? Because the duplicates are gone, right? So if there's not any duplicates, the lengths would be the same after we remove the duplicates, right? Because if there's no duplicates, then we don't remove nothing, right? We don't remove anything, right? So the lengths will be the same. But after we remove them, the lengths will be different, right? That means there are duplicates. That means we return. So here, then what do we return? Do we return true or false based on the problem? Do we return true or false? And let me erase this. Could someone write it maybe? Return true or false? Okay, so the problem states that when there are duplicates, we return true. Right? True, right? Otherwise, we return false. False. Right? Boom, that's a problem. Right? That's it. That's all we need to do. Right? So we kind of just wrote the whole code actually, right? So this is the whole code, right? This is literally just the Python code, right? So kind of wasn't really pseudocode, but it was just a whole solution because this was one of the shorter codes, right? So does this make sense? This problem. So let's write this in leak code right now. So let me stop this whiteboard. Remember, does it make sense? Let me know, okay? Let me know if it does not make sense. Okay, so let's write it in here. Right, so we had our nums. Well, we have nums, right? Nums is given to us. Right, so we have nums, no duplicates, equals to len, or equals a set of nums. Right, and all we did was if nums, no duplicates, right? The length of it, right? The length of nums and duplicates is not equal to the length of nums, then all we have to do is return true. Otherwise, we return false. Right? That's exactly what we just read. Right? Oh, and I don't really need because I'm sure it'll work. But and we click submit and let's see what happens. Oh, cool. We it works. Right. So you can does this solution kind of make sense? How we got from being in the dark to now kind of like getting the solution. Right? We made an observation. Right? Problems always have there's always some observation that you have to make some very neat trick that you can kind of do. Right? You kind of see that how we rephrased it, right? Instead of saying, okay, we want to see if there are duplicates, right? Our first goal is to see if there are duplicates in the list, right? And we kind of rephrase it, say, okay, if there are duplicates and I remove the duplicates, then the length of the list will change, right? That's the observation, right? So if the length of the list doesn't change after I remove the duplicates, that means there aren't any duplicates to remove, right? That means there's no duplicates in the list, right? If so, that means that so our observation was then if the length of the list was equal to the length of the list after we remove the duplicates, right? Then there aren't any duplicates in the list, right? Does that make sense? I'm gonna see some things in the chat. So yeah. So yeah, sometimes the runtime is like a little bit weird. It's about the server that you're on. So sometimes it might get fast, sometimes it might get slow, but I think it depends on if it works, awesome. Right? Try to maybe, just do like a plus or minus like 25. Like that's like the range that your problem, like your thing beats. Right, cool, awesome. So now let's do this new problem. This new problem is a little harder and it does I'm not sure if we'll be able to finish this in time, but this thing teaches binary search. So we will do this in the hopefully you guys remember the binary search where we learned that like maybe like a month ago, where we had like a couple practices with this. This was a practice with binary search. I think we had like two more other problems that we did. One homework, one we did in class. Oh, we had three, right? One I explained. Well, no, we had four actually. Right? Two I explained, one you had for homework, and one you just did by yourself. Right. So we had a few binary search practice problems, right? So hopefully you guys can still kind of get the gist of it in your mind, at least the understanding of binary search, right? So let's read this problem and let's see how we can approach this with binary search, right? Because without binary search, I think it might be the problem. Like the problem might be a little harder to understand if you don't use binary search, right? So here, while using binary search, I think you should be able to understand it pretty well. Right, so given a sorted array of distinct integers and target value, return the index if the target is found. Otherwise, we return the index where it would be if it was inserted in order. So this sentence might be a little confusing. You'd be like, okay, what does this mean? Right. So there are two conditions that we could take away from that sentence alone. This is a very information-packed sentence, right? So the first, like, I guess the first condition is, okay, if we found the target, if the target is found, we just return where we found it, right? And example one tells us this, right? Because 5 exists right here, we return the index where we found the 5, well, 0, 1, 2. That's where we return 2, right? Because we found 5 at index 2, right? If it doesn't exist, we want to put it where it would be if it was inserted in order. What does that mean? So if let's look at example 2. Okay, let's look at example 2. So target equals to 2, right? Okay, we want to see, okay, if I were to put target, if I wanted the list to be sorted, where would I put target? right? If I would definitely put target between 1 and 3, right? That means I would have to put it after 1 and shift 3, 5, and 6 to the right. Or like move that whole chunk to the right. So it becomes 1, 2, 3, 5, 6. That's why output is 1 because we put it index 1. Right, so let me maybe if I write it a bit easier. Right, so like 1, 3, 5, 6. If we want to put 2, we want to put it between these, right? We want to put it in the middle between here. We want to put it after 1 and before 3. And to do that, we have to open up like another space to do it, right? And you might think that's kind of what happened when you're approaching the problem, right? You think, that's a little complicated, right? Like we have to, I don't know, make space for like another list and then like do all that stuff. Like that's a little complicated, right? But you kind of think like, do we really have to make another space and get the index, right? We kind of know where we're gonna put it, right? Because no matter what, right, when we're putting things, right, we want to put it between 1 and 3. So we know it has to be after 1. And technically, doesn't this thing that we put in the middle just go where the 3 was, right? It kind of goes where the 3 was, right? And it shifts 3, 5, and 6 to the right. Does that kind of, can you kind of see that? Like when we want to put target between 1 and 3, right? We want to put it after 1, right? So we have to make another space between 1 and 3. But doesn't that technically just go where 3 was originally? Right? Can you guys kind of see that? Can you guys kind of see that? Right? Does that kind of make sense? Yeah. Right. So that's kind of the observation, right? Like sometimes you guys, your brain, right, because it's just the common way of seeing it, your brain actually makes it harder for you, right? Because your brain makes it harder for you because that's how you would normally see it, right? Like we're gonna make a space, right? And then we put 1, 5, and 6. That's how it works, right? That's how it logically works, right? But if you can kind of rephrase the problem to like, okay, instead of making the space, and solving the problem by just making that space, right? Can't we kind of see, okay, if I just know where I want to put it between, right? If I know where I want to put it between, right? Where am I gonna put it? Like, where's it always gonna go, right? When I'm putting it between. So if I want to, when I'm putting it between two numbers, well, I'm gonna put it in the index where the bigger number is. Does that kind of make sense? I'm gonna put it in the index where the bigger number is, right? So now all I'm trying to find actually is okay, the index where the like the index where there's like two numbers, right, that are just in between two, right? One number is above two and one number is below two, right? And they're adjacent to each other, right? And then I want to just put it in between them and it's gonna go, that means it's gonna be the index of the bigger number. Does that kind of make sense? It might be a little confusing to understand, but I want you guys to kind of see it is when I want to put 2 between 1 and 3, it's always going to go to the index where 3 is, right? Because it's going to take up the spot where 3 originally is, and it's going to shift 3, 5, and 6 to the right, right? So does that kind of make sense? Can you guys kind of see it? So now my goal is to find, because the list is sorted, right? The list is sorted, so every number will be increasing. So I'm going to find two adjacent numbers, right? I'm going to find two adjacent numbers where 1 is less than 2 and 1 is greater than 2, or 1 is less than my target and 1 is greater than my target, right? And I'm going to put it at the index where the greater number is. Does that make sense? So I'm going to return the index of the greater number when I find the number that's first less than target and the number that's greater than target. Does that kind of make sense? Can you guys kind of see that? Please let me know if there's any questions. I know it might be like a little confusing, but let me know if there's any questions. Okay. Maybe you guys are typing in the chat, so I'll wait like a minute just so maybe you guys can finish whatever you're typing in the chat. Remember, if I'm talking a little too fast, you can always look at the captions at the bottom of your screen, right? Because that's like a whole paragraph, right? It just says what I said before, and then it's pretty accurate sometimes. Sometimes it messes up, but like most of the time, it's pretty accurate. Okay, so hopefully you guys understand what I just explained. So now we just rephrase the problem into, okay, I want to find two numbers that are right next to each other, right? That first have the one number that's less than target and one number that's greater than target. And I'm going to return the index of the number that's greater than target, right? Cool. So how might we use binary search, right? How might we use binary search? So let's give me one second. Let me open up another whiteboard. Um, whiteboard, new whiteboard. Okay. Hopefully you guys can see the whiteboard. You guys are following along. Okay, awesome. Cool. So our list first, let me just copy our list. 1, 3, 5, 6. 3, 5, 6. Okay, so remember binary search, we have 3 pointers, right? We always have, let me do the pointers in another color soon, right? We have our left pointer. This is cursive out. We have our right pointer. We have our middle pointer. Right? Remember, our middle pointer is always equal to the value of the right pointer plus the value of the left pointer divided by 2. And we round down. Right? We round down. Right? So if it was like 2.5, we just round down to 2. That's why this m is right here, because let me draw the index in like a different color. So green, 0, 1, 2, 3, just to make it easier for you guys. All right, okay. So middle will equal to 0 plus 3 divided by 2, which is 1.5. To round down is 1. Right? So that's why the middle is right here. Okay, cool. So let's think about it like this. Remember, we always look at a middle pointer. Always look at the middle pointer, right? So let's think about it this way. We want to look at the middle pointer in kind of we want to always compare the middle, like the value at the middle pointer, with target. Okay, we always want to do that. So, how should I explain this? Let me give you guys something like, okay, so let's just say this is nums. Oh, why so thick? Nums. Oh, should make it another the normal color. Nums. Right? Okay. So nums at m is just gonna equal to the value at n, right? In nums. Hopefully that makes sense by now, right? You guys kind of know how to index things, right? Okay, so let me ask you guys a question. So when nums, let's do the easiest one. If nums at m equals to target, what does that mean? What condition did we just meet? When this happens, what do we do? Right? Remember, you guys remember the first condition was we return the index of the value if the target is found. Right? So all we have to do is return n. Return n. Right? Because when nums at m equals target, that means at index m we found target. Right? So that was condition number 1. Right? So if that never meets, then we want to find where we inserted it. Right? So let me ask you guys another question. If nums at n is bigger than target, what does this tell me? If if nums at m is bigger than target, right? Doesn't that mean that, okay, the list is sorted, right? So if nums at m is bigger than target, that means everything to the right of m will also be bigger than targets, right? Because it's a sorted list, right? So everything to the right of m, right now, nums at m is bigger than target, right? Nums at m is bigger than target. So we have 3, 5, and 6. Right? 3, 5, and 6 are all gonna be bigger than target. The mid is too large. The target is less than mid. So we narrow down the left of the mid pointer to, okay. Okay, you might have to be like a little bit careful. So is the left pointer, or are you sure it's the left pointer? Because remember, the left pointer is gonna be, well, the left pointer. You sure it's the left pointer? So right now we're talking about nums at m being bigger than target. So when nums at m is bigger than target, we know that every single value to the right of m will be every single value to the right of m will be how do you put this? Every single value to the right of m will be bigger than target, right? Yeah, will be bigger than target. Great. Okay. So now we know that if nums at m is bigger than target, we want to find the value where target is less than or equal to some value and immediately greater than or equal to the, or sorry, we want to find one value where target is bigger than a value, right? Target is bigger than a value, and then also less than a value, like its neighbors, right? It wants to be bigger than its neighbor and less than its neighbor on one, and we want to choose the index of the bigger neighbor, right? That's what we just said. So isn't that kind of, you can also rephrase it like, okay, I want to find um where we want target. I want to narrow down my search range so that I find the perfect target value, right? So let me just into another position and get some water so I don't cough that much. Yes, I know. That's yes, that's so when nums at m is bigger than target, right? I don't care about any value that's bigger than target now. Right? Because well, I don't want to put target there, right? We're not gonna put target in between a value that's bigger than it and then the rest also bigger than that. That's not what we're supposed to put the value, right? So like we're not gonna put like the two like right here, right? That's not just how it works, right? So now we can lower our search range, right? We can shrink our search range a little bit to, right? R equals to right? R equals to m. Okay, well, and we can even do R equals to m minus one because we also know that m is bigger than target, right? So now, right now, our search range is like shrunk, right? It's shrunk now, and let's do it bigger than m. R equals to m, just so it's like a little more, maybe a little more intuitive, right? So now our search range. Let me move the m and the r. Now r is here, right? Because we just set r equals to m, so m was here before, right? So now also, and sometimes they might be in the same place. M is going to be right here. Why? Because 0 plus 1 divided by 2 is 0.5, round down to 0, right? So m is right here. So now, right, we want to see, okay, if nums, nums, less than targets, right? If um if nums at m is less than target, now like what does that tell me? Like what does that tell me? What does that tell me? I want you guys to like try to answer this. What does that tell me? What will this tell me? Like chat. Let's make sure you're not. I want you guys to like try to tell me. I don't know how this goes. L equals. Okay. Yeah. Oh, I know. I just want some like other people to give me the answer because I think you know it. So just wait for some other people. And like anyone else, like maybe Elena, Danny, Alan, Phoebe. Like give me some feedback. Let me know. Oh, and just so we save some extra time, it's gonna be m minus one because at m it's also bigger than target, right? So our goal is to kind of find It's kind of okay. It's kind of hard to explain. But let's think about it this way. So we want to find, okay, we want to find the value. So that what we just said, right? What we've been saying is that we want to find the value that's where m is it's like it's kind of its neighbor will be bigger than it, and its other neighbor will be less than it, right? So we found the perfect position for to put it in between, right? We return the index of the bigger value. We can kind of phrase it so then we find the let's see, how to explain. We find like the closest value to it, and then that's bigger, and then we return the index. So does that kind of make sense? Like, can you guys kind of like understand that? Like, we want to find the target, the value that's closest to target, that's bigger than it, and then we return the value. And that's always where target's gonna be. And return the index, not the value, sorry. Does that kind of make sense? I'd be like a little bit confusing. Kind of makes sense. Oh. Okay, I want you guys to give me some feedback because that's like a little confusing. So again, like I want to find the target value that's closest to it, that's bigger than it, and I want to return the value. And I want to return the index. Because remember, we just said, right, when where I'm gonna put target to the right of it is gonna be bigger, and to the left of it is gonna be smaller. That means the value to the right of it that's bigger, we want to put it there. We want to put it there, right? So then that value will be the closest value to it that's bigger than it. Why? Because the next value to it is smaller than it, right? So and it's always increasing. So like it's gonna get bigger and bigger and bigger and bigger the further right we go, right? So when I want to find the value that's bigger than it, I want to put it there. Right? The closest value that's bigger than it, I want to put it at its index. So my goal now is to find the index of that value that's closest to target and it's bigger than target. Does that kind of make sense? I know it's a little confusing, but I want you guys to give me some feedback. Just say yes or no. Does it make sense? Does it not make sense? Okay, because it's 52, so I want to finish the problem because I was gonna give you guys another problem to do, but it took a little longer explaining than I thought it would be. So I mean, you guys, I don't see anything in the chat, so I'm guessing it makes sense. Okay, I'm gonna guess it makes sense. I'm gonna guess you guys got it. Okay, so cool, right? So now, right, let's go back. We know this is definitely true. When target is bigger than when target, okay, when nums m is bigger than target, we know that the search range will go to r and to m minus 1, right? Because then now we're searching for all the values smaller than it, and then our goal will be to return. We want to find. Okay, L will be our answer. So L would be. Let me put this in my nice book. L would be our answer, and why will L be our answer? Because binary search will always kind of work like this. So L, okay, so it'll kind of work like this. So we first have our search range, right? First have our search range. So let me show you guys. Let's just start from scratch. I'm trying to think about like a way to explain it that's like intuitive to understand, because this it does take a little bit big understanding of binary search, but I'm trying to like break it down. Okay, so and you guys are smart kids, so I know you guys can understand this. So our goal is we could return m as well, right? But I want to explain this way we return L because it's like a little bit more intuitive. So R, right? L and R is always going to be our search range, right? Between L and R will always be our search range, and middle will just be between L and R, right? So when we're trying to find the closest value to target that's bigger than target, right? So and we return the index of that, right? So our goal right now is three. You can clearly see that, it's three. So you kind of see that, okay, right? Kind of see that. Um, and it's not just it's total it's just a coincidence, right? So you can kind of see that when we narrow down our search range, right, eventually, right, R will always be it's gonna be because we did R equals to n minus one, right? It's always gonna be less than less than it's gonna be one less than the value we want eventually, right? Because we're always like trying to shrink it down, right? When m is bigger than target, we're always gonna get the m minus one, so it's gonna be less than target, right? Or yeah, it's gonna be less than target eventually, right? Because when it's bigger than target, it's gonna go to a value that's like when nums m is bigger than target, right? It's always gonna go to a value because we did m minus one, that's gonna be less than target, right? Does it kind of make sense? It's eventually gonna go to a value that's less than target, right? Because eventually we're gonna find the value that's just bigger than nums m, right? It's just bigger than nums m. It's bigger than it. So nums m, yeah. Wait, when nums m, yeah. So we're eventually just gonna r equals to m minus one will eventually get us to the value that's it was just bigger than target. Now it's gonna be right less than target. Does that kind of make sense? I'm gonna give you guys some time to like maybe think about that. Remember, please let me know if it doesn't understand. Like I know it's a little hard to explain, but I was gonna explain it like one way, and then I realized like that way might be too complicated. So like, does that kind of make sense? Like, let me know. Um, you guys aren't typing anything in the chat, so give some time to like maybe think about it. Okay, so one person maybe. What about everyone else? Two people? Okay. I want to go with like a majority, like maybe one more. Okay. Okay. So, okay, it's 57, so I'm just gonna move on. Please, like, hopefully, I just really want you guys to get it. If you guys just let me know that you don't get it, I can help you. But if you guys don't understand it and you don't let me know, then I can't really know, right? So, right, because nums at m, when nums at m is bigger than target, right? We already know it's bigger than target. So eventually we'll like shift it. We'll always decrease R, right? When nums at m is bigger than target, we're always going to decrease R, right? So R is closer, it's going to get closer and closer to m until it's going to go, it reaches m and it's going to go one less than m, right? Because when it's bigger than target, right, the next value we'll move it down because we do minus one, we do minus one. So it'll be right next. So this will be right less than m, right less than m, right? So just less than m, right? And now when nums left equal to target, I'm gonna do L. Oh shit! I'm gonna do L equals to n plus one. And what this will do is it'll give me the value just bigger than target, right? Just bigger than target. Why? Because well, when nums at m is less than target, right, we're gonna be increasing the value, the index of R. Sorry, the index of L, right? Just it just keep getting closer and closer till it gets closer, and then we do plus one, so we just get right. So eventually, in some cases, right, L and R will kind of swap places, right? Eventually, we're gonna see L become uh go right here, and eventually we're gonna see R become right here. And that's perfect because now we just found where L is, right? And we want to do this because we're always trying to get R closer, closer, as close as M to possible, and then right one less than it, and L as close as possible, and eventually right bigger than it, right? And what this will do is it will keep the search range right? So then we'll still be less than like our search range as it goes, right? It'll keep on being so that um the value we want is in the range between L and R. But eventually when they cross and flip, right, then we find our answer, right? It's kind of like that. So I hope you guys can kind of envision it that like right now what we're doing is we always want to keep um the value that we want, which is 3, right? For example, we always keep it between L and R, right? We don't really know, we just know it's in the range. So we always keep it between it, and eventually we get very close to it. We get just at it and we flip, right? We flip L and R, and that means we know that we found our value, and our value is going to be at M because we know that we want to get the value bigger, right? We want to remember our first goal, right? We want to find the neighbor that's one less than it and the neighbor that's one greater than it, right? Or that's one less than it and a greater than it immediately. And we want to put it where the bigger value was. Hopefully you guys understood that, right? Because we want to get to the value that's bigger than it, right? So because we're gonna shift all the values that's bigger than it to the right where we insert it in between, right? Like we want to put R here, so it'll basically take up where the 3 was originally. That's why it's the bigger one, right? That's why we will return L instead of R, right? So now when we flip, right, L will just be in the position that's just bigger than, right? That's just bigger than target. So we found our answer, right? So our answer will be L. Does that kind of make sense? I know I kind of explained it a little fast because it's already 5. So maybe you guys have a class after this. I don't want to take up another teacher's time or things like that. So does this kind of make sense? Because we're just getting closer, we're getting closer, we're getting closer while keeping our answer between our range. And when we flip, we found our answer. Does that kind of make sense? Because we want to get just closer, just closer, just closer, just closer, just closer. And when R flips, right, and L, all in all will flip because L will go to the bigger value and R will go to the smaller value. So now we have L and R, right? This is L, this is R, and our value is supposed to go right between, right? We just found out what we were saying at the start. Right now, L will be the value that's just bigger than it, R will be the value that's just smaller than it. So we went to the bigger value, so now we return L, right? Does that kind of does that kind of make sense? And let me just quickly write the code so then um it'll work. Can it make sense? Okay. Um, I, I hope it makes sense. Like again, I want to make sure you guys understand, right? Because I understand the code, right? I understand it. Sometimes, like, sometimes, right? This, yeah, this screen share. Sometimes, like, when um, like, I understand the solution, right? And sometimes, because I made this slide like a while ago, sometimes I might like forget the solution. So I also kind of solve it with you guys, right? You guys can kind of see that like how I think about it and approach a solution, like is like I'm also kind of in the dark, like in the same position as you guys, right? Like I didn't memorize the solution or anything, right? I'm kind of just like going about it and solving it as we go along, and that's how you guys should tackle every single problem, right? Like you should build the intuition to solve the problems, right? It takes time and it's a little challenging, but I know you guys can do it, right? All you have to do is just give me a little feedback sometimes when I explain the problem so I can help you guys out and try the problem yourself and always just try in class, right? Try in class, right? And I know maybe it's winter break, so it's like maybe it's like time to rest or something. I don't really know. Right? So let's define our pointers. Right? We always define our pointers at the start for binary search, right? So L will be start at 0, and R will start at a length of nums minus 1, just so first it encompasses the whole list. The range is the whole list, right? So let's and now how we standard usually do binary search, right? While the left pointer doesn't cross the right pointer. Right? I can't see anything. Is this it? Okay, hopefully you can see. Wait, am I sharing the red screen? Oh, there you go. This is the red screen. Okay, is this the red screen? Okay, cool, awesome. Okay, so remember, we want to define M, right? We want to, what is M, right? Remember, M is L plus R divided by 2, round down. Remember, this is 4 division. Hopefully you remember what that is. Right? If, oops, M equals, sorry, equals to target. So remember, that's condition 1, right? If and is less than target. Norms bigger than target. At the end, we return. Let's see if this works. That's kind of what we just said, right? What we were writing before. Okay, and we submit it. Oh, cool. Oh, we beat 100%. Cool. I think this was because I got a good server. So depends, still like a plus or minus 25 again. So I should be beating about 75% of people to 100% of people. Right. And this solution, not me, right? So does it kind of make sense where we're getting closer and closer and closer to it until we flip and then now we find our range. Right. Yeah, of course, of course. So that's why I don't really want to go over it. That's why I was going kind of fast. If you want the recording, I'll post the recording. And next class, I think we can just continue the problem I was gonna do this class because it kind of spent like more time than I was expecting. So let me go fast and then no homework this class. Very cool, awesome. Make sure you understand the solution, right? Make sure you're able to do the problem by scratch, right? From scratch, you want to be able to understand the problem, the intuition, not the solution to the problem, right? Yeah, and then I hope you guys have a good Christmas, right? Christmas is upcoming. Hope you guys get a lot of gifts, have a lot of fun, have a lot of eat good food, have good rest, right? And then I think we'll meet next week, and next week we'll go over the problem again. Okay, I think we'll meet next week. I'm not quite sure. Okay, so I'll see you guys next week. Okay, good job today.
Bye.
Yeah.